Your AI model knows the answer, but it keeps picking the wrong word. This is because greedy decoding gets stuck on local peaks. Today we reveal how Beam Search balances efficiency and quality to fix this. Let's start with the problem. Greedy decoding picks the single highest probability word at every step. While fast, this strategy often leads to grammatically incorrect sentences that make no sense in the long run. Beam Search solves this by keeping track of the top K candidates, known as the beam width. Instead of following one path, it explores multiple possibilities simultaneously to find a better global optimum. This approach directly impacts performance metrics. Research shows that Beam Search can swing an LLM's exact match and BLEU scores significantly without even changing the underlying model weights. However, there is a critical trade-off you must manage. Larger beam widths improve quality and accuracy, but drastically increase computational cost, requiring more processing power for each generated token. Because of this trade-off, researchers have proposed simple modifications, like a single line of code change, to further improve decoding performance for strong neural language generation models. In conclusion, Beam Search is the essential bridge between raw speed and high-quality text generation. It allows us to generate coherent, human-like text that greedy decoding simply cannot achieve on its own. Now you understand the trade-off between quality and compute. What beam width would you use for your next project? Let us know in the comments below.